Welcome back, everyone, to The Deep Dive. Today we're going kind of deep into the world of machine learning. Specifically, we're talking about one of the 5 tribes of machine learning, the symbolists.
That's right.
And, you've probably heard of machine learning. I mean, it's everywhere these days.
Yeah, it really is. I mean, it's one of those things that you don't even realize how much of your life it's actually impacting. From the moment you wake up and you check your phone, I mean, if you have a smart home, the lights come on in a certain way or the temperature adjusts, your smart speaker tells you what the weather is like outside.
Right.
You go to work and maybe you're using some kind of CRM system or some kind of business intelligence tool that's powered by AI. And then you go, throughout your day, you're shopping online, you're watching videos, you're listening to music, and all of that is powered by machine learning in some way. So right. I think it's one of those things that we really do take for granted.
Well, yeah, and I think what makes a symbolist unique is that they see machine learning as not just, a tool for prediction, but rather a way to unlock some deeper truth that's hidden within data.
Yeah, I mean, they're very much focused on the logic and the reasoning behind the patterns that we see. So they're not just interested in saying, okay, well, we see that this happens and then this happens.
Yeah.
They want to understand why that happens. What are the underlying rules and principles that govern that behavior?
And this is where their perspective comes in.
Right.
Viewing learning as the inverse of deduction.
Exactly. Yeah. It's a fascinating way to think about it. So instead of starting with rules and deriving a conclusion, if you think about classical logic.
Right.
If you have, all men are mortal, Socrates is a man, therefore Socrates is mortal. They're starting with the conclusion. So they're saying Socrates is mortal. We know that all men are mortal, therefore Socrates must be a man. So they're working backward to uncover the logic that led to that conclusion.
Right. It's almost like a detective novel.
Yeah.
Where you have the murder or the crime that's taken place.
Exactly.
And you're working your way back.
Exactly. Yeah. And I mean, one of the best examples I think to illustrate this is in medical diagnosis.
Right.
So if you think about how doctors traditionally diagnose patients, they look at the symptoms, they look at the patient's history, and they try to come up with a diagnosis based on their knowledge and experience. But what if we could take that process and reverse it?
Right.
What if we could start with the diagnosis and then work backward to figure out what symptoms and what history would lead to that diagnosis?
So in that case, you're not just treating the symptoms,
Yeah.
You're actually going after the root cause.
Exactly.
Yeah.
That's right. Yeah. And that's what symbolists are really trying to do with machine learning. They're trying to figure out what are those underlying causes? What are those underlying rules that govern the behavior that we see?
So it's like a deeper understanding of the system as opposed to just reacting to the outputs.
Exactly.
Right.
Yeah.
Yeah. That's fascinating. And this is where these fields like philosophy and psychology come into play.
Right.
Because it's not just about logic.
Yeah.
It's about understanding how humans think and reason.
Yeah. Absolutely. I mean, one of the key insights of the symbolist approach is that human reasoning isn't just about logic. It's also about things like beliefs, biases, and common sense knowledge.
Right.
Things that we take for granted as humans, but are actually very difficult to program into a computer. So symbolists are trying to figure out how to represent these kinds of concepts in a way that a computer can understand. And they're drawing on insights from fields like psychology and philosophy to do that, because these fields have been studying human reasoning for centuries.
Yeah.
So there's a lot of knowledge there that we can leverage.
So are they trying to almost create machines that think like humans as opposed to just machines that are intelligent?
Well, I mean, it's a little bit of both.
Right.
Because ultimately, we want machines that are intelligent, but we also want them to be intelligent in a way that we can understand and that we can trust. And I think that one of the best ways to do that is to try to understand how human intelligence works, and then to see if we can replicate some of those principles in machines.
Right. So you're not just getting an output, you're understanding the why behind the output.
Exactly.
Yeah. Right. And, speaking of that, how does that inverse deduction that we were talking about earlier, how does that make the conclusion more likely?
Well, it's all about increasing the likelihood of the desired outcome. Think of it like a puzzle, right? You have all these pieces and you're trying to put them together to form a complete picture. The more pieces you have, the more likely it is that you'll be able to complete the puzzle.
Okay.
In the same way, inverse deduction is about gathering as much relevant information as possible to support the desired conclusion. So the more evidence we have, the more likely it is that the conclusion is true.
Oh, I see.
It's like building a case in a court of law. The more evidence you present, the more convincing your argument becomes.
So it's not just about finding any solution. It's about finding the most likely and the most accurate solution based on all of the available information.
Exactly. And that's what makes the symbolist approach so powerful. It's not just about pattern recognition. It's about understanding the underlying logic and reasoning that led to those patterns.
That's incredible. So you're not just getting a prediction, you're getting an explanation.
Exactly. Yeah. And that explanation is crucial because it allows us to understand why the prediction was made. And it allows us to trust the prediction more.
And that's super important, especially as these machine learning systems are becoming more and more integrated into our lives.
Oh, absolutely. I mean, we're already seeing this in areas like healthcare, where machine learning systems are being used to diagnose diseases and to recommend treatments. And it's incredibly important that we understand how these systems are making those decisions, because ultimately those decisions are impacting people's lives.
Right.
So transparency and explainability are absolutely crucial.
That makes a lot of sense. And it sounds like the symbolist approach is really well suited for addressing those challenges.
Yeah, I think it is. I mean, because they're so focused on logic and reasoning and on understanding the why behind the what. I think they're in a really good position to develop these kinds of transparent and explainable AI systems.
So this is really fascinating.
Yeah, it is. It's a really exciting area of research.
It is. And we're just getting started. We've got a lot more to dive into when it comes to the symbolists.
We do. Yeah, we haven't even scratched the surface yet.
So we'll be right back after a quick break to continue our deep dive. Stay with us. Okay, so we're back and we're talking about symbolists. And one of the things we were talking about before the break was how they incorporate prior knowledge into this whole process. And I'm curious about that because, it seems like it could be really complicated to take all this existing knowledge that we have and kind of bake it into a machine learning system.
Yeah. Yeah, it definitely can be. But that's where the real power of this approach lies, because instead of starting from scratch every time we try to solve a new problem, with symbolists, we can actually use what we already know to guide the learning process.
Right. It's like, if you're teaching a kid how to ride a bike, you're not going to just, throw them on the bike and say good luck.
Exactly. Yeah, you give them training wheels, you hold onto the seat.
Right.
You give them some kind of support.
You give them the tools they need to succeed.
Exactly. Yeah. And that's what symbolists are trying to do with machine learning. They're trying to provide that scaffolding, that framework of knowledge that allows the system to learn more effectively and efficiently.
So can you give us a concrete example of how this might work?
Yeah, sure. So let's imagine that we're building a system to diagnose diseases. Right. So a traditional machine learning approach might look at a patient's symptoms and try to find patterns in the data. Right. But a symbolist system could actually go further, and it could incorporate existing medical knowledge about diseases, about their causes, their treatments, all of that stuff. And that would allow the system to make more informed diagnoses. So it's not just looking at the symptoms in isolation, it's taking into account the patient's medical history, their lifestyle, all sorts of other factors that could be relevant.
So it's almost like having a team of doctors working behind the scenes.
Right.
Providing their expertise to guide the diagnosis.
Exactly. Yeah, and that's what's so powerful about this approach. Because you're not just relying on the data, you're also incorporating human knowledge and expertise.
So it seems that this ability to combine data with prior knowledge, that's really what sets the symbolists apart and allows them to uncover these deeper truths.
Absolutely, yeah. I mean, one of the things that symbolists are really interested in is this idea of going beyond correlation.
Right.
So a lot of machine learning systems today are very good at finding correlations in data.
Yeah.
They can say things like, oh, well, people who buy this product also tend to buy this other product.
Right.
Right. But they don't necessarily understand why that is. And symbolists are trying to get at that why. They're trying to understand the causal relationships between things. And they believe that one of the best ways to do that is to incorporate prior knowledge into the learning process. Because oftentimes that prior knowledge contains information about causal relationships.
Right. So it's not just about making predictions, it's about understanding the underlying mechanisms.
Exactly. Yeah. And that's really important because if we want to build AI systems that we can trust, we need to understand how they're making their decisions. We can't just treat them as black boxes. We need to be able to look inside and see what's going on.
Okay, so this all sounds incredibly promising. But are there any limitations to this approach? I mean, it seems like it could be computationally very expensive to integrate all this knowledge into a machine learning system.
Yeah, that's true. It can be computationally expensive, and that's one of the challenges that symbolists are working on. But I think it's important to remember that computing power is constantly increasing.
Right.
So what might have been computationally infeasible a few years ago is now becoming increasingly possible. And as computing power continues to increase, I think we're going to see more and more applications of the symbolist approach.
So as technology improves, we can expect to see even more powerful symbolist systems emerging.
I think so, yeah. I mean, I'm very optimistic about the future of this approach. I think it has the potential to revolutionize a lot of different fields, from medicine and scientific discovery to finance and cybersecurity.
Yeah, it's fascinating to think about how this way of thinking, could reshape our world. I'm particularly intrigued by this idea of, machines not just processing information, but like actually understanding it at a deeper level.
Right.
What are some of the implications of this for the future of AI?
I mean, that's a big question, and one that I don't think anyone has a definitive answer to yet. But I think it's safe to say that the symbolist approach has the potential to lead to more transparent, more explainable, and ultimately more trustworthy AI systems.
Mm-hmm.
Systems that we can understand and reason about rather than just accepting their outputs as black boxes.
Right. That's really important, especially as AI is becoming more and more integrated into our lives.
It is, yeah.
It's crucial that we have confidence in these systems.
Right.
And that we understand how they're making decisions that affect us.
Absolutely. Yeah, I mean, trust is going to be key to the widespread adoption of AI.
Right.
And I think that the symbolist emphasis on logic and knowledge and transparency is crucial for building that trust.
This has been a truly insightful conversation. It's clear that the symbolist approach to machine learning is not only fascinating from a theoretical standpoint, but also has the potential to unlock some incredible advancements in a wide range of fields.
Yeah, I agree. It's a really exciting area of research, and I'm eager to see what the future holds for this approach.
Absolutely.
Yeah.
And for those of you listening who are as captivated by this world of, knowledge and technology as we are, be sure to like, share, and subscribe for more deep dives into the most intriguing corners of the intellectual landscape.
Yeah, please do.
We'll be back soon with more mind-expanding exploration, so stay tuned. It's really remarkable to think that we could potentially bridge that gap between human intelligence and artificial intelligence by incorporating these principles of logic and knowledge representation.
Yeah, I mean, that's the dream for a lot of symbolists, right? To create these AI systems that don't just mimic human behavior, but actually possess like a deeper understanding of the world, just as we do.
And that kind of raises the question of, are there limits to this? Like, are there certain aspects of human intelligence that you just can't replicate through logic and symbolic representation? Like, what about things like creativity, intuition, or emotional intelligence?
It's a good question. It's definitely a topic of debate, but I think a lot of symbolists would say that while some aspects of human cognition might be harder to capture than others through those purely symbolic means, our understanding of those concepts is always evolving. As we learn more about how creativity or intuition or emotions actually work in the brain, we might find ways to represent them symbolically as well.
You're saying it's not necessarily about like drawing a hard line between what machines can and cannot do, but more about like pushing those boundaries, seeing how far we can go with this symbolic representation.
Exactly. It's about exploring the full potential of this approach and seeing how far it can take us, on our quest to really understand and replicate intelligence. It's a fascinating challenge.
Absolutely. And as we've been, going deeper into this world of machine learning, it's clear that the symbolist approach offers, this really unique and valuable perspective by combining the power of data with the richness of human knowledge. They're paving the way for a future where AI systems are not only intelligent, but also, comprehensible and trustworthy.
I think that's spot on. And for anyone listening who's intrigued by this idea, this intersection of technology and philosophy and human cognition, I'd encourage you to explore the world of symbolists even further. It's a journey that can really challenge how we understand ourselves and the machines that we create.
And if you enjoy this exploration with us into the fascinating realm of symbolists and their quest for knowledge through logic, be sure to like, share, and subscribe to The Deep Dive for more mind-expanding adventures into the world of ideas and innovation. Until next time, keep exploring, keep questioning, and keep learning.